Hello, Professor.
Okay, hello, Sarah.
Hello.
We have a new toy installed by the end of semester. So let's wait, maybe more people will join. So now you can see yourself, right? Okay, someone else is coming. Hello, Lina, how are you? So there is no special program for today, just let's prepare for the reports and presentations, and I will just walk around and help us as much as I can. So the reports are due on the night before next class, so Thursday midnight. And for presentations, based on time of our meetings, there is a reserved exam time, and do not fear the word exam. We do not have exam. We have presentations. I know that it's easy to scare someone. So, but there are class reservations based on the schedule, and they call it exam. Again, it will be presentations, and for those who have labs at Wednesday night, it's suggested that we make our presentations also on Wednesday night, but I'm not sure if it is the best time. And we were discussing, I suggested to check if everyone is happy about Thursday morning, but it looks like for me, it's a conflict schedule, quite strong. So maybe, what are you thinking about Friday morning?
I'm agree.
Huh?
I'm agree with Friday.
You okay or you against?
I'm okay.
Okay.
Yes.
I'm open. My Friday is like not busy, so we. Oh, and later you cannot. You can later.
I prefer to be at 9.
Okay. Lina wants everyone to wake up by 9. Make everyone happy. Does anyone has schedule conflict on next Friday morning?
That's because we have grad final thing at 11 this Friday.
Group meeting?
It's physics department organization called.
Okay.
Now I'm vice president, and the president is not here, so I have to.
So you need to complete by 11.
Yeah.
Okay.
What about Wednesday or Thursday?
No, Wednesday is not a good time, Sarah, because Wednesday 6 to 9 or more than 9. So it's like midnight. So that's why Professor thinking about morning.
So Thursday is.
Yeah, but Thursday Professor busy.
What? Wednesday. Oh yeah, sure. Yeah, Wednesday at 6 or maybe Friday at 9. Okay, and I do not know schedule of all special circumstances. Is it land free time on Friday so that everyone can eat and get energy for presentations? What's the schedule when it's okay? I'll ask it personally so that everyone feels. But let's maybe tentative. So Lova is for Wednesday. And
Disadvantage could be, I think, because we won't like worry about the time. It could be like not thinking about what we have next.
oh, okay. And what's how long is your committee meeting on Friday?
1 hour.
So another option is Friday at noon, at 12, after your committee. I'm not pushing. I'm just exploring opportunities. Okay, so if you do it, if you start it at noon on Friday, then Lina is happy. What? Kea, you raised hand ahead of everyone, and I didn't ask. Is it about schedule or about something different?
No, something different.
Okay, let's solve about get some idea about schedule, and then we'll discuss different things. So, what about Friday noon? Is it too late for someone? Or maybe it is possible, but someone is not happy. Boston is always flexible. Thank you. Stephen, it's fine. Vova, do you have any plans for next Friday noon? Is it okay? Or you prefer Wednesday evening? So you have some plans for Friday afternoon, right? Complicated. Sarah, what are your preferences?
Friday noon and Wednesday both work for me.
Sunday, Friday noon. Okay.
Okay, I have no issues on Friday. Means Friday, it's okay.
Okay. So on Friday, everyone is.
Take more than 2 hours.
I want to finish it in an hour, but who knows? Maybe this discussion will go longer.
I saw Professor. I saw the last year video. It was less than 3 hours.
What? What was less than 3 hours?
Everyone present their project work, and the question answer session will be finished within less than 3 hours. Means the video you uploaded.
You won't ever. My wish that we finish within 1 hour. Maybe it is not possible. No, 3 hours. Then I will leave everywhere.
No, you will not. You will be there.
So what's your deadline? By which time you want us to finish? On if you start later on Friday, if you if you need to fly or drive somewhere, is it just not comfortable? Or you have something scheduled? From 9 to 11 you would be fine, and later you are not. Okay. So if you start at 9 and move Lina closer to the beginning, that she can leave earlier, then everyone will be happy. And there are high chances that we all will be done in 2 hours. So let's meditate and think on it a little bit more, but tentatively let's plan on Friday, because Thursday would be like really hard for me. Specifically this Thursday, there is some unexpected appointment that I need to do. Okay, good. So now, Kea, your raised hand.
Yes, Professor, because I just finished the presentation of the another class, and I didn't start to write the report for this class. So I'm not sure that I'm able to finish this one by tomorrow. I'm not sure. I will try my level best, but I'm not sure.
So I understand that probably not only Kia, but everyone is worrying about their. No, no, you only Kia worrying. Everyone else is okay.
Okay.
That's yeah. Well, but this is normal. Come on, you are literate. You can type quickly if you have something to type. But it will be first draft, and we do not have option to postpone it because on Friday is our only meeting when we can meet and review works of each other. So we will play a game. Each of us will play a role of reviewers. Yes. And after reviews, reviewers will return the works and comments back to authors, and there will be more time to polish it. Until Sunday night for sure, maybe even a little bit longer. So by Sunday night, just send me if you are done. If you need a couple of days, tell me personally. So here is the reason I am hiring a local publishing company so that they compose your works in a little book, and they need time to process. If you have some last minute changes, it's very easy to replace, but they need to format, like they need to know the number of pages for each work. They will already reformat like fonts, and it will be much, the earlier the better, but I'll try to have it printed hard copies before our actual presentations. So Sunday night is preferred, but like a couple of additional days will be okay. So consider to send like final or semi-final version by Sunday night, and then you will have day or two to add more changes if needed. If it is not drastic, if you're not shrinking it 2 times or expanding it 2 times, it's just little corrections, it's fine. Is it reasonable and doable? Kia, are you not fearing anymore?
Sorry.
Are you okay with this explanation? No
Yeah.
fears anymore?
No.
Okay, good, thank you. So I will not make a individual like guidance for the whole class today. Please just log in and complete whatever is left to the project, and I will stop by and ask what are the open questions. And I'll probably, I already have something prepared on the screen related to Steven's project, and then I'll just go circle inside the class and then circle outside of the class. So just prepare your questions, and I'll try to spend maybe 10 minutes per case, and then if there will be time, maybe make a second round. Steven, are you going to leave somewhere? Because I was going to show something for you. So here is the Vesta software that you may want to install. And I think Boston already has it. So if you do not feel comfortable asking me where to take and how to install, you can talk to Boston. And your original model boundaries. Well, it's a good software for everyone, but if your research is not on periodic models, then it is kind of secondary. One, apply. So your periodic model has only 2 ruthenium and how many? 6 chlorines, right? And for humans who are not in this class, it's a little hard to imagine that this little thing that looks like a molecule is an object of much more atoms. And you saw it in VMD and also in Vesta. There is a way to expand it by like 2 times in X direction, 2 times in Y direction, and then it looks a little better. And also you may offer your help to everyone in PChem class. And if you offer them figure like this, that literally shows 32 ruthenium atoms and how they are arranged in space, they will include you into co-author. Like all 9 works will have dual authorship. So you may consider doing it. And it just shows the model and explain the concept of periodicity. Now, the same, so it's nothing about science, it's more about visual representation. Here is your model in VMD, right? So pink is ruthenium, greenish is chlorine. And then one can open, browse, charge car, open, file type, was charge car. So if you load spin up plus down, it will be homogeneously covering all ions. So it will be like basically circles around each ion, both organic and inorganic. And if you open the same file but select the second option, up minus down, it will show spin density, which has almost nothing in chlorines, and most spin density is only in ruthenium. So this is definitely an illustration of antiferromagnetic, where the same spin is on both atoms. And if you try to do the same procedure for antiferromagnetic, it should show as good as nothing. Another little trick is, instead of showing these bubbles, one can show the slice, which for some people it will be more visually appealing. Surface move, volume slice move. So this draws the charge density distribution as function of 2-dimensional thing, of 2-dimensional coordinate. And for your problem, it could be quite interesting and reasonable. And one can move this slice, and the images on this ruthenium atom is kind of superposition of not only d orbitals, but all orbitals on d atoms. So it will look almost as shapeless, but it's kind of interesting. And there is a very little bit on chlorines, and it looks like these dumbbells, balloons, but they are almost invisible. So probably you have a plan of doing 1,000 other things or dozen other things for your report, but consider to make it more visual, which may benefit Okay, Boston left. Any questions from you, or any emergent questions? Okay. Do you have challenges to complete calculations and logically present what you have, or you have too few information and you need more ideas to do more calculations? So you do not need to answer right now. You may just meditate on this question, and when I'll stop by, we'll chat. Boss, I'm very happy to see you. I was going to approach your seat, but since you are not here, I was in doubts what to do. I see raised hand by Kia. So if you
Yes.
Yes.
So, Professor, I have one question that if I want to submit any job using the premium.sh, so is there any limitation for that?
5 jobs simultaneously.
Sorry.
5 jobs, and since we are like 6 people in the class, there will be definitely a conflict. Someone will not be able if everyone submits one job. So premium allows only 5 simultaneous jobs.
Okay, that's why it shows that there is a limitation like this. I just able to submit.
Regular doesn't have limitation. You can submit like 10,000 jobs, and debug allows only 2 jobs, and premium allows only 5.
5. Okay, I already submit 2. Then they showed that there is a limitation.
Yes.
Error. You are not able to submit that job.
There is a chance that someone in the class will be angry on you because someone also may also want to submit premium job.
Okay. Okay. Another question that you were showing this one, just for curiosity. Means there is a plate like this. I don't know the color. So it's how you show this one, not the violet one. It's rectangular, that plate. Yeah.
This one?
No, in the left side, this one, there is, yes.
So
There is a rectangular plate, like it's like a.
yes, when you plotting charge density, you can do create rep, then drawing method. Instead of isosurface, you can do volume slice.
Okay. Okay.
Okay.
Yep. Volume slide. Okay. Okay.
Okay. I'm going to talk to Boston, but then there, like prepare your questions.
Okay. Okay. I don't.
Emailed you yesterday about that state.
Did you saw my answer?
Yeah, I saw and I tried doing.
Wait. Did you try to watch the .pdf file? Where it is?
Oh, I haven't looked at the PDF file.
No, please show it first, and then let's speak about other things.
Can you try to open that in NERSC somehow? Is there a way to open it in NERSC?
No. Here is the thing. There are fun stuff, and there is adverse things that are not as pleasant. And why computational groups need graduate students to do exact transfer files.
So
Kim? So it does work?
Yeah,
right?
yeah. So I saw that and saw that it had worked. I hadn't opened it though, but
Did you need to practice it for other
yeah,
configurations?
that's what I was gonna ask about, because I tried to go do what you had shown in my anion one,
Uh-huh.
and when I was trying to do that, it gave me these errors. So I did almost exactly what you had done in
Okay,
here.
yeah, let me see. Okay. Let me just try to type it. Mm, okay. Uh, I'm just giving some. Um, did you change it back?
I haven't touched this, so I don't know what was
It-
wrong.
I think you did. Well, maybe there is some wrong coincidence, but I remember that I was editing it. Let's recompile. Do you understand what is going on, or should I give?
Not really. No, I was actually gonna ask you.
I expect you to know Fortran.
Okay.
Is it true? So you need a little time to recall it.
Fortran, I've never mentioned, not touched Fortran before, so I'd have to.
So size for the variables where this are stored were defined 5,000 when writing this code. I never thought that anyone needs more than 5,000 orbitals. So I need to change it to a bigger number. And, after recompiling, so of here G Fortran, name of the Fortran minus output, and then name without .f. So it compiles it, and then if you write 17 to 15. Mm. So we actually need maybe from 3 to 7, we need positive values. Okay. 80 what?
This would be 86, 84 is neutral with the CNI.
Okay.
Okay, perfect, thank you. So essentially all that I had to do was change that.
The dimension
Okay.
of this variable. Okay, good.
Sounds good, thank you. And should that be, if I go and start doing that the other ones now, should it just be fine?
Yeah. Oh,
Okay,
yes, yes,
okay.
yes. Can you show this PDF once again?
Oh, yeah, I'll have to do.
No, you'll do it on old PDF from previous thing.
Oh, I see.
Just bring it up. So we need only a little segment near the gap.
Yeah.
Okay. And also, did you compute this anion yourself?
Yes.
Okay. Which submission script did you use? You were doing it on
I
CCast.
did this on CCast, yeah.
Okay. What's the name of the submission script?
It'd be byte job.
Uh-huh. Byte, it's good. Byte job.
And then I have a brand the standard one if that's what you're looking for.
Okay. Right now, in the lack of time, do whatever you can do in the limited time. But if you are thinking of continuation, just plan on doing NCL everywhere. It's just safer. Then you do not need to think.
Okay. Even just like standard runs, but for like.
For everything, and withdraw this command only if job is too complicated, takes too long. But if it is a small system, then if there are no limitations on time, NCO is like the best thing that LASP can offer compared to Gaussian. And if some reviewers will complain, just tell them where is your spin orbit, and I do have it. And for these heavy items like Witmas, it's good to have.
Okay, I'll use what I have now for
Yes.
report on Friday, but I'll try and run these ones on
Mhm.
CCast with the NCL.
Yep.
Okay.
And again, right now it is secondary. It will become primary later. Explore if it is fun for you. There is nothing pushed, but consider to explore online WASP menu for specific additional commands for spin orbit coupling. There will be like they're basically LS orbit equals true for magnetic for orbital momentum and spin activate, and there are just a couple of additional commands which will make it more efficient. Not for now, but I'm just putting seeds of thoughts.
Okay. Sounds good.
Any other questions?
I might have some later, but I'll let you get.
Okay.
everyone else
Yeah.
too,
Yeah.
so.
Yeah. Thank you. And you did orbitals.
That's one of the questions I was going to be asking about. I was plotting some of them. They didn't really look right to me. So I was going to see if they look right to you, but
Okay.
okay,
Yeah.
I'll let you work them because I still have to do those.
Uh-huh.
So.
And did you do molecular dynamics?
I have plotted it up, but I have not run.
Okay. Yeah.
So,
It's good. So what's your plan? What do you want to include?
Calling the dots well enough.
Uh-huh.
Susceptibility specific heat with magnetic field
Based on what? Based on MATLAB or based on VASP?
based on MATLAB.
But I upload, and I'm very enthusiastic about it.
Scale it back.
I am applauding to your plan and your effort, and I am very enthusiastic about it. But here is the unique opportunity to bring in ab initio contribution. So let's put, do not cross it, but put it like priority number 3. If you complete as much as possible with VASP, then you can later on add these calculations. And the best, if you really think, and there is a big chance for publication in this thing, is to combine ab initio data and MATLAB. On its own, both ab initio and MATLAB will be not competitive. Upon combining, they will be like one can even try for some high-ranked journals. But the bottleneck is VASP. Without VASP, it will be only scholarly exercises. Okay. Do you have plan for MATLAB? Oh, sorry, for VASP activities, or you need a little more time to think?
Planning instead of the DOS.
But those not the MATLAB those that you saw in PChem, but the actual DOS that we do for this. Okay. Yes.
The
Good.
DOS from, so I moved all of those to initial.
Mhm.
So calculated this DOS.
Aha. Oh, for spin up down, for spin polarized.
Yes.
Okay. Good.
But that was using files that were not explicitly ferromagnetic or anti-ferromagnetic. So for consistency with the calculations that I've done that have the explicit ferromagnetic, anti-ferromagnetic information.
Mm-hmm. Yep. Okay. Good. By the way, did you check which configuration is the one that you did without constraint? There is a high chance that it naturally comes to ferromagnetic. Did you check? Do you know how to check?
Well, from when I read in the docs, you have documentation. I think it was anti-ferromagnetic.
But can you open OZCAR? Just right here, just double click, open. So magnetization 2 means 2 spins are collinear. So it's already anti-ferromagnetic. So your task is twice as small. You just need to explicitly compose anti-ferromagnetic.
This is the ferromagnetic or anti-ferromagnetic?
This is ferromagnetic. It may contradict to expectations and to experiment. And explanation for this is that here we allow spins going only in Z direction. It's like no orientations. And maybe it is the only thing that we can do in the remaining time. But if you're curious to explore beyond this, then you can, of course, do not forget to open new directory for any new calculation. You may try to rerun the same thing by using, and on the Photon it is not available. It is not compiled, but you should do it on CCast or better on NERSC. So VASP and CL. Just a minute ago, I recommended to Boston to do it. Underscore NCL. NCL for non-collinear. So it allows spin to be to take any directions. Not only, yes, of diagonal elements in the density matrix, and if one composes 3 projections, then there are actual spin SX and SY, while in stuff that we are doing right now, it's only SZ projection. SX and SY predominantly 0, they are disabled. there, if you do Vespasian, there is a chance that the lowest state will be antiferromagnetic. Like the result that right now the ground state is ferromagnetic is a little is contradictory to expectations, and likely it occurs. It happens because of the disabled SXSY, and you're not competing for Nobel Prize yet, so you can just. You can disclose it that I'm doing it under approximation of collinear spin.
The primary problem is that spin. This is the structure of
Mhm.
But your samples of crystallographical samples, I should put that way. Crystal structures of alpha RUCL is not equal. Gamma and beta are equal. Alpha is shorter. And so that results in this.
So maybe it is not as crazy to have antiferromagnetic in ground state. Yeah, it will be interesting story, but I don't know if you can bring in graphene right now. It's possible, but not on such short notice. Yes. Did you? What else? Or if you just try to develop plan, like what is the goal, how you plan to achieve it, and which additional illustrations? Of course, you are already grown researcher, but if you share with me the plan, I can just provide some feedback to optimize your effort. So I have a feeling it is not ready yet, but try to think and just scratch on the paper when I do next circle. Just make like I would do a flow chart with plan of logic. What is my goal and how I want to achieve it? But maybe you have different mindset. Just think what is available, what is possible. Like, is it possible to do absorption spectrum, or maybe it is not needed? Is it possible to do dispersion, same as Boston is doing for two-dimensional, or maybe it is not needed here? Did you try to run molecular dynamics, and what would you see there, or is it needed or not needed? So here is my little attorney advocating of the molecular dynamics. And it is hypothetical. Maybe it's a wrong direction of thinking, but why I would do molecular dynamics if I would do this project? As we go through thermal motion of interatomic distances, local crystal field around each ruthenium atom slightly changes, and it may favor or disfavors ferro and antiferromagnetic. And can you bring open Aussie currents again? Yes. So at each step of molecular dynamics, it writes F instead of F equals, it writes T equal and puts temperature. And at the end of such line, and if you do molecular dynamics for 1,000 steps, it will show like from 1 to 1,000. At the end, it still writes magnetization. But there is a chance that along nuclear trajectory, magnetization changes, which will mean spontaneous change of the ground state. So it is not an average over microstates. It's not as high level as what of statistical mechanics of doing partition function. It's only swapping like ground and second state, but it still could be interesting, and it may be a phase transition again, not in the sense of magnetic origin, but it could. Motion of nucleus could be transitions between crystallographic phases. So if it goes fairly, it will be cool. If it fails, then you can either report failure or just exclude it from the report. Okay, so please think and include some wild ideas, and you refine to make it minimal. Also, I always feel very nervous when I see laptops that are not being charged. Okay, I'll keep making a circle. How are you?
I'm good. So try to
And you do everything in new directory, right?
yeah.
Okay. So I spin 2, number of electrons and up down. Can you and something? Oh, okay. Yeah, good. Now, did you do the spin? Yeah, states up, states out.
So I'm just running fast.
Uh-huh.
I'm waiting for it to get up.
Okay. Can I
Yeah.
type something? So you're okay with it not being charged?
No.
Okay. I feel so nervous that it suddenly will stop, so I'm trying to keep it plugged every second. Is it okay if I'll go to different directory? You'll be able to navigate this one back?
Yeah.
Okay. Maybe something changed, but last night it was already spin polarized. Yes. Spin component 1 and the occupations are 1. Not 2, but 1.
But I didn't edit the info file. How come it has been okay, yes, it has been component, sure.
Okay. So what one needs to do is to extract spin up and spin down. So the spin component 1 taken, this part will be spin up.
Yeah, but this
Just wait. VI should just stay. So there is no states up. VI states up. Hi. And oh, okay. That's okay. It just raised. Yes.
Yes, you can try.
Can you do it for me? I'm a little stupid. Oh, yes, sure. Thank you. Good. Escape. Now, let's do it once again. I know I'm not doing it in the elegant way, but it's more reliable. I will go to spin component 2. And we look for the region of energies a little bit below, a little bit above Honolulu. Copy. Down. Fine. I learned it from you. Paste. Okay. Escape. WQ. Now let's make sure they have the same. starting from 72. Tail ending 99. And we need to remove the last line. States up. So from 72 to 99 now. Now from 72 to 99. Now they're equal. Okay. Once again, more states up. For states up, last orbital is 84. 4 states down. Last orbital is 83, right? So it's different homos for up and down. This one is doubled. Okay, and now you just look how to convert this, follow the same procedure as for triplet and make this green and red spin polarized dose. Make sense? Okay, so please do it and then I'll stop by once again.
Yeah, that's what's running to the triplet.
Basically, you're doing the same thing.
Yeah, that's what
Okay.
it looks like.
Yeah, so you didn't read the outcar because it's so long and boring.
No, I actually did read out.
So if you see this once, it means it is instead of two, it's the spin polarized. And you probably looked on the more states, which had two, right? But it was, we may copy the
So
just.
confused. When we did VI states, it was one, right? It was, the occupation here was one, right?
So this one is inherited. Remember when we were creating many of these directories together, we just copied everything and didn't erase this. So it's just
I just didn't run it as up down spin.
okay.
So I can go ahead and plot.
Yes, for the
Yeah,
yes, yes.
I can just kill this one. I was going to do the same thing.
Basically, yes. Basically, yes.
How do I stop this one?
Are you sure that you want to kill it?
Yeah, that was what I was going to do.
Okay.
What you did was what I was
Okay.
going to do.
Okay. So kill -9, 33, and look for the number here.
Okay, 595.
And now try PS once again. So West photon is killed, and there is no among the, so it's killed, right?
Okay. So go ahead and do dress.
Dress those up, dress those down. Yes. Oh, beautiful pictures.
I just want to check the pictures if I need anything
Uh-huh.
else. So I will start with the atomic model, and then I have the partial charge density. And I have density of states. I will add the separate models too. So this is for everything.
Yeah. Everything is great. I just have a very quick comment.
Okay, sure.
Please do spin up and spin down.
Oh, okay. I
So
wanted to ask how
it
to
shows,
polarized
yes, yes. So we, in your calculations, I spin equals 2, right?
So what?
Nothing new, I'm just repeating.
Mhm.
No, in your calculations, the in-car file includes the keyword I spin equals 2.
Yes.
And if I spin equals 2, it means there are spin up and spin down components. And if there are spin up and spin down components, one needs to plot density of states separately for alpha and beta, which will be like red and blue things.
Yes, yes. I put the note here.
Yes.
I will add this.
I noticed it because it shows this, as we discussed with Lola in the spin polarized calculations, occupations of orbital is 1, right?
Yeah.
And this code for without spin polarization was assuming that it will be 2, so it's 2 times smaller.
I think this too. So about the heating,
Mhm.
So I just used the video that you
Uh-huh.
took this snapshot.
Yeah, excellent. This is great. This is great.
Okay, so
I-
what I need
I'm-
just to explain what's happening for all the bonds. in
Yeah,
here, right?
yeah, and do not write a dissertation, just a couple of sentences.
Yeah, I noticed like, so I just need to understand something. So heating in this period of time, this is all changes happen. So
Molecular
this
dynamics,
return to
yes, molecular dynamics after heating, right?
Yes. This is after.
Yeah. So after molecular dynamics.
Yes.
Okay, now let's look here.
Mhm.
So can I draw something? I'm going to ask you. I will draw something, and then I will ask you to repeat or just speak about. So it is your optimized model before molecular dynamics. So
This is before.
this is carbon,
Mhm.
this oxygen, this is oxygen, this is nitrogen, and here are the three hydrogens: H1, H2, H3. So can you please label this whatever 7 atoms on the last step of molecular dynamics and explain what did happen? Just please try to.
Oh, no.
Yes, right here.
So we have oxygen. Oxygen, there is a hydrogen here. And I have carbon here. Carbon.
Okay. Where's
So we have
nitrogen?
2 hydrogen here.
Okay.
So it was, yes, it was 2 oxygens here, but then the hydrogen from this part comes to here.
So it was hydrogen transfer
Yes.
or proton transfer, whatever it is.
Yeah.
Okay.
Okay.
And it did happen spontaneously, right?
Right.
We didn't manually move it. It
Yeah.
just you hit it, and then it's a little chemical reaction of proton transfer.
Yes.
And so the system doesn't want to have deproton so this H1, if hydrogen without electron is proton, right? Proton. Carboxylic group typically has hydrogen.
Yeah.
And if we remove hydrogen or remove proton,
Negatively charged.
it becomes COO minus. So this is carboxylic protonated because it has this proton.
Yeah.
This is carboxylic deprotonated. And if you read
this term before, but I didn't understand.
so you start with deprotonated form of carboxylic group, and then spontaneously during your molecular dynamics, carboxylic group arrives to protonated form. So it's a little discovery, right?
Yes.
And then this nitrogen group with additional proton, it was charged positively, and this one was negatively. So it was a big dipole. And
Yeah, this is what I noticed. I was thinking about it should be
Yes.
polarized to be
right.
blind.
Right. It's a good word for explanation. So it was polarized.
Mhm.
And then after your chemical reaction, we didn't check it, but there is a hypothesis that the dipole was substantially removed. So smaller dipole, and maybe one can use the word depolarized.
Depolarized. Okay.
I'm not.
Which make it like kind of weaker binding.
Yes. So it's weaker binding, but the molecule itself becomes more stable.
Yeah.
Because this protonated is more so now
Because this energy.
carboxylic group is neutral, and this amine group is also neutral. So
yes, it has just 2 hydrogens now.
Yes.
Oh, okay.
So carboxylic neutral and amine is neutral.
Neutral. Okay. The amine is neutral and here is neutral.
Yes.
The more stable.
So you did discover a chemical reaction on surface of gold.
Don't feel like that.
And I don't know if time allows, but again, it's only as a food for thought. One can take the geometry after this reaction and repeat things like that, like make density of states and orbitals and see what did change.
If I remove an atom.
No.
the electrons.
No. I'm not telling any new information.
Yeah,
So I'm thinking and speaking very slowly. You do have several geometries, several geometric configurations. One before molecular dynamics. And then after you have several steps of molecular dynamics, you have configuration geometry after. Now, for the configuration before the reaction, you do have plot of orbitals and you do have plot of density of states, or you will have it soon. But for the geometry after reactions, you do not have orbitals and you do not have density of states. But you can, even in the given time, you probably can do it.
Can I use all five in MT600K?
Yes, take cont car from there and push it into a new directory, cont car into new directory, rename it as a postcar, and just do the same characterization, density of states and orbitals. And as a result, you will see what thermal motion made for your model. So first, it made a chemical reaction of proton transfer, and second, likely it will change density of states, and likely it will change pattern of orbitals. Like here, for this LUMO orbitals, it was hybridization between this oxygen and gold, and maybe after the reaction, this hybridization will disappear. I do not know. It's on hybridization may disappear. Hybridization may disappear. Yes. And those discoveries are little. They're not yet for a Nobel Prize, but those are objective scientific information, and potentially they're sufficient for some low to mid impact journal, if it is presented well. It's well. Let's finish the in-class report first, and then talk about it. But if there is potential, I'm not kidding.
Okay, so what I have to do now, I will do density of
Or-
charge density, I mean, with
and density. Yes.
Contour and
For the last snapshot of the dynamics.
the first one here, this 5,
Yes.
MT600.
This directory, yes.
Okay. Okay. So I have contour, and what I should do? Just do the steps similar to here.
Yes.
Here, on this
So
directory.
we create directory. So make directory it after MD, and we copy there, and we will name it as postcard.
Mhm.
We also copy all other.
Postcard
Mhm.
and wavecard.
Yeah, but not necessarily. It can do it. Wavecard can be missing because it whole time was shorter. Yeah, and this submission scripts. Okay, and we do not need in-car because we need it over here. Copy template of the
Card geometry
yes.
optimization.
Yeah. Okay, and just and after it is done, you can
Just same process to find.
first do density of spin polarized density of states, and then do orbitals, and you do not need anything else. It is already a strong work, and
Yes, okay, so I will do these and density polarized.
Mhm.
So it's just for the whole system,
Yes.
not necessary for.
If time allows, you can edit, but let's do the minimum and explain it in text.
Okay, so here
So by Thursday evening, by Thursday night, if you do this and explain it by words, it could be sufficient. Later, for the final draft, you can add those for these things. But
this week, this for after, plus this for both,
yes.
and these after.
Mhm.
Yeah, that's fine.
So
And then everything gets.
yeah, and just then make process as you typically process scientific papers.
Yeah.
Oh my pleasure.
This is the first time in my life. I'm
But
so
what you-
proud of myself.
Yeah, you're doing good. You're doing good.
Thank you. Effort.
Yes. Yes.
Plot absorption spectrum. So, am I plotting absorption spectrum for this?
This is not easy. And can you bring image of the DOS, of the spin polarized DOS back? Okay. So there, I do have codes, and I will share with you. But first, let's talk and I explain. So there are two spin components. There are two types of transitions: transitions of alpha electrons and transitions of beta electrons. So it will be basically as two spectra that we connect together. And same as you did DOS up, DOS down, same it will be spectra up, spectra down. There are scripts, and this is possible, but this is a little. There is a way to simplify the procedure, which is basically redo the same configuration with non-collinear spin. So even if you are not doing it right now, I just want to inform you that this is available. So there is a way to make VASP calculation that combines both spins together, not as occupation of two electrons on one orbital. It will be still different spins, but it will be one list of occupation between 0 and 1, so that it will combine them better. And then the spectra will be much easier to compute. So just, even if you stop here, it will be good for the project. But I'm just giving you a little seed for thought. If you're not tired of thinking. I see, yeah. But there is a so-called non-collinear spin. So your request to me is to give you codes to make spin polarized spectra, right?
I mean, you suggested it.
Yes. Do you have a piece of paper? So I have a little, yeah. It's not task for you, but suggestion. So would you, I will go talk to others, but would you please draw a sketch, a plan, like which figures you want to include in your report, and what is the logic, like just what you want to include in your report, which figures, how they're connected to each other.
Okay, I have it here.
Okay.
So,
Okay, so those are it's really good, but it's good. Maybe so let's do it together. First, you do have anion 1 spin polarized DOS. What is the number of this figure? I'm not asking you to answer right now, but later. Okay, you do have spectra absorption, and I do not know what they are. So question, which configuration? Which configuration? And is it like neutral, anion, cation?
it's neutral.
Okay, absorption for neutral. What's the figure number? We do have energy as function of number of electrons. What is figure number something? And then you have several spin polarized DOS triplet, and it is neutral, right? Neutral. Again, what is this figure number? And I'm a little tired to screen all of them, but not physically tired, just intellectual. Let me show what I mean. So, for example, we can do this one, figure number 1. This one will be 2. This one will be number 3, and this will be number 4. And then the story will be that first we scan energy, So this is neutral, this is anion. Then we connect from here. We go to density of neutral. Then after we go to density of anion, which is this point, and then we go to absorption spectrum, and maybe next.
This should be 3, so this should be 4. So like this
Yes,
will
yes,
come
yes,
to
yes, yes, right. And then maybe figure 5 will be orbitals for both neutral and anion. Figure 5, and then from here we go there. So it's only a sketch. Maybe you can do better, but please plan to make a plan of logical connection, like what approximately what you expect to find and how to connect information between each other. So you have basically everything or almost everything. And now the most biggest challenge is how to present and connect them logically. So do not rush. Good logic is more important than to amount of figures or amount of writing. So I hope that you are tired but not super tired. So I'll do another circle, and when I return, you will either refine this plan or design something new, and we'll discuss it again. And it will be really helpful for putting together your report. Does it make sense or not? Okay. Any questions right now or any objections? Okay, so just try to think and maybe either refine this or design something better. I think we are on the right track, but it needs some input from you because I.
I'm looking at this. Since the orbitals overlap, does this mean it's optically active or not? Because like they have some areas that might.
You did something wrong with this data. Oh no, not here. Wait. Wait. Why don't you include into the table the third table here? No, insert table. No, I'm a little stupid, but you may add
I
more.
copied and pasted
Uh-huh.
them.
Yes, but you can add a few more rows, and for comparison, put there also HOMO and LUMA, like 83 and 84. And then we can compare what will be the oscillator strength and transition energy. So if here is large, and I'm very curious to see what will be oscillator strength for HOMO LUMA. Oh, you have answers for everything. Wow, impressive. You're basically done.
It's a long data actually. I don't know how you can do find
In command,
83.
how to do in command line, I would answer immediately, but I hate Excel. It's a little. Oh, they are arranged in descending order. Okay. Do you have this oscillator strengths in command line? Then I'll find much quicker.
I'm trying to know which of these folders.
Let's try together. So it is neutral, right? Right?
Yeah, yes. Just go back to the.
No. Absorption. I think it is abs. Okay, now let's do sort minus GRT 1, 2, 3, 4. So those are transitions with largest transition energy, and if you remove the reverse, show the smallest from HOMO to LUMA, this much. So oscillator strings
Very small.
very small but non-zero. And for this, by quantum theory, you will be able to repeat it and find it later, right?
Mhm.
I'll put TOP that it doesn't log you off, but sort based on the numerical value of the column number 4. So it sorts the way the row with lowest value in the column number 4 will float to the top. It was what I was telling. So if you do sort without GK, it will sort alphabetically based on the first column. Now it sorts G means numerically based on numerical value, and K means column number 4, GK4.
Okay.
So it sorts the file in such a way that the column with the minimal value of in the column 4 will float up. Now you see it increases 0.5, 0.6. So it will be all optical transitions. Come on, it is I should ask you this. If you would have an exam, it would be perfect exam question.
Okay, Lewis. Oh yes, it makes sense.
Maybe you need to just stop now and get relaxed. I think.
No, no, wait, I can continue.
But it's.
Yeah, it makes sense because like every atom or whatever is trying to go to the lowest
Mhm.
energy. Yeah, makes sense.
Okay. Yeah.
Okay.
I see it was a long day.
Yeah, it's been a long. Okay. So I should include that.
Oh yes, and into the table, it will be much more reasonable and it answers your own question. Please bring me back to where we. Yes. So it has a lower value because the transition has charge character, right? Charge transfer from metal to ligand. So you can tell it that it is LMCT.
Is what?
LMCT. Did your rotation advisor and Steven use this language for you?
I think I saw this in what MCT they have. Metal complex.
Charge transfer. Let me write it down.
Did you not, Steven, you know?
Steven, you didn't teach her what is LMCT. You do not know it yourself? I will complain to your advisor.
He said, what is LMCT?
You know it.
They only told me charge transfer. They explained charge transfer.
So-
but I don't know what is LMCT.
So no. Ligand to metal charge transfer.
What we are seeing here, you can see that the orbitals are mostly concentrated around our metal core here. But then for our highest occupied state, when we go to our LUMO, we see that charge is dispersed across the ligand. So we have ligand to metal charge transfer. Now, if we saw instead that we had the density was mostly over on this, and then it was mostly over on this for our LUMO, that would be MNC with LLC.
ML.
Ligand.
Oh, ligand to ligand. Okay. And now let's go to your. So, and this one is ligand to ligand charge transfer.
Yeah.
Okay. So you can characterize it and in your text when you're explaining these results. So LCT, right? So it's quite cool. Okay, I don't remember why I asked it, just because of the orbitals. And those are for neutral, right?
Yes.
Did you do orbitals for this anion?
No.
So I strongly recommend that you just finish making plan and then go relax. You will be much more productive if you just relax and do it tomorrow. But let's just finish of discussing this plan and will be enough for today.
Okay.
So if you do orbitals for anion configuration, they likely change their character. So HOMO to LUMO will be something different, and most efficient charge transfer will be also something different.
Which would be should I? Which would be? Which of them should I look at?
So this was neutral, and your result has minimum on anion here, anion 167, right?
Mhm.
So make orbitals for this.
I have to then change. Do I have to change the in-car part? Do I have to change anything in the in-car? You know, I have spin up. I spin.
Let's do it together right now. Yeah. I know through your homeworks, I know you already did such exercises before, but let's do it together.
That one doesn't have.
So one. Okay. Now, oh, you already have those up those. When did you do it? Huh. You're so quick.
Yes, that's what the doublet I showed you.
No. Oh yes.
Yeah.
Yes.
Oh, I just did it. Like when I was showing you.
Oh yes. I'm also tired.
Tired.
I was teaching another class this morning, but Steven was helping me. He doesn't look tired. You were coming to the PChem class this morning here, and you do not look tired because you are like stronger. Okay, so make directory PC for power charge. Okay. Now copy conf car into PC, and we'll rename it as postcar. We also copy their standard service files like key points, car, and we can also copy the wave car because we need wave car for orbitals. Good. Let's check once again. States up. So we need maybe. Well, let's do first just a couple of orbitals, and then you later can do more. So from -4 to like 1. Okay. CDPC copy in car PC spin here, and we should run it in just in car, and we need to put the right number of electrons, otherwise it will be everything will be corrupted. So grep number of electrons in the out car 67, right? It is for anion. Copy. I
found something.
Huh?
I found something when you select to copy. You don't need to click on copy, just copy it.
Oh, I can do paste right away? Oh, thank you, thank you. It's really helpful. You taught me many good things. You taught me that one can allow another party on Zoom to control screen. I never knew about it. So, oh no, number of electrons, but I also need number of bands. Okay. Number of electrons is okay, is correct, but I also need to update number of bands. So let's check what was number of bands. Yeah, National Basketball Association. So one.
So I'm going to ask, why did number of bands increase here? Because for the neutral, it's 109.
Oh, I was going to blame you for this because you distracted.
I'm sorry.
No, that's okay. That's okay. I should be more concentrated. So why number of bands is different? So there are additional procedures that we didn't discuss in class, but the code is written this way. They try to take larger number of orbitals and see if everything stays the same, if the precision will be better. Because the larger number of orbitals, the more precise DFT calculation is. So it automatically updates it. So we have n bands with number of electrons, but we do not have the energy range. So from -4 to +1, let's here. -4. Once again. -4 to +1. Good. Wave curve was read successfully. Okay, and after it is done, you can just plot a couple of orbitals and compare how orbitals in neutral and in anion are different. So it's an interesting story. I don't think today is. It may take too long, but I'll try to identify scripts that will get spectrum for spin polarized and share maybe during the night so that at morning you can practice, or I will tell that let's forget it forever. Right. But just try to combine the data that you collected along this plan, or maybe slightly updated, but make us like hear how I see it. Maybe you'll see it a little different. We first explore how the energy depends on number of electrons, and we identify which is most probable electronic configuration. And after we get this information, we compare the configuration we started from, neutral, and the optimal one. And then we compare how their density of states change upon adding additional electron. We look how orbitals change upon adding additional electron, and we look how the absorption spectra change upon adding additional electron. And then that's it. That's the story. So basically, the story is how the properties, optical properties of a molecule, yes, are changed upon injection additional charge. And if you have chemical background, maybe it's upon reduction. Like if you do this electrochemistry cell, you know this reducing, oxidizing. So if you reduce the molecule, would it become brighter or darker? And it's a little short story, but it's very interesting. And maybe after all these things, you can add absorption spectrum from DFT and tell if it agrees with this story or not. But that's it. That's enough. Mhm. Mhm, mhm. Okay. So when you do this spectrum, you finish it at 700 nanometers.
Yeah.
But you should go a little further. So let me show it here. Um, prog SPE nanometers. See, there are several. You use just simply GNU prog nanometers, right? And there are additional like from 300 to 1300. If you will use this one, then it will make a wider thing. How do you do spectrum? You type GNU plot and then name of the script, right? Instead of typing GNU prog SPE nanometer, you can type GNU prog SPE nanometer underscore 300. That's it. And then finish procedure in a standard way. Enough. I think you have more information that one can finish in 1 day. I'm tired for myself and I'm tired for you. Okay, I think we are done. Yeah, I recommend you just if you want to finish something, please do. But it's better if you just go and accumulate strengths for the next day. Oh, okay. Now it's time to speak to online part of the course. Kea, you have raised a hand for last 2 hours.
Yes.
Oh, sorry. So let me stop sharing on the other computer. Stop sharing. Yeah, so I should make you the co-host. Yes, and I should make Sarah co-host. Yes. Do we
The
have
thing
anyone
is, Professor, I don't have any question right now.
I do not believe you. You are kidding. Typically, you have 3 times more questions than anyone else. And you're asking questions for another half an hour after the class. No, you should have some questions. I do not believe you.
No, you should. I already sent you email. So you,
I apologize. I will not read emails right now until
no, not right now. Means later, because those things are different. It's not. You are not. Those things I need maybe few discussion. I already sent you email, and I want to start writing. That's why if you allow me, then I want to leave. Right.
Oh,
Right now, I don't have any question. That's the thing. That's why I raise my hand. I don't have any.
Oh, okay. No, you're very welcome to disconnect. Well, I will miss seeing you during the rest of the class on one hand, but on another, I will have more chances to talk to others.
The thing is, okay, I want to focus on writing.
Yes.
Then
Let me
obviously,
tell what we were
if I have any question, I will send you email.
So here, let me tell you what we were discussing with Boston,
Okay.
Steven, Lola, and Lina.
Yeah.
So we were discussing the flow chart of the figures for the paper. Like in the last lecture, I was giving approximate set of figures, but each project is quite individual, and maybe I'm confident that you know what to do. But if you are planning to disconnect right now, please try to maybe you already did what I'm going to suggest, but make a plan, not showing figures, but write by pen and paper list of figures and their content, and sketch how they're connected to each other. So to make
Okay, okay.
story before you start writing a lot, before you start putting all figures, because I know that you generated huge amount of data, and it is a little challenge to connect logically everything. So maybe show not all data, but part of them, but make sure they're all connected to a single story.
Okay, I already share with you. So do you want me to share those figures again?
I remember. I just want, if you do not
I
question.
know how to connect those things because I prepare like those way that I will able to connect
Sarah, is
each
it okay
and
if
everyone
Sarah, is it okay
together.
if Kia briefly shows her figures?
My figure?
Oh, yeah, yeah. Yes, Kay, please share.
Just 1 minute. I need to open the slide, that's why. Okay. Professor, are you able to see my screen?
Yes, yes, I see your screen.
Yeah.
I do have a question. Why you are placing, why are you doing two figures of density of states? Why don't you connect all 6 figures for density of states in one super figure?
So you want me to add, means this,
Like 6
this
panels
and this,
from like
9
9.
figure together?
Yes, like A, B, C, whatever letters.
Okay, okay. I was thinking
More
about that, but
dense and a little easier to
and also I told you that before submitting the final report, I will actually reduce the, I will show from -1 to +1. Means I need to redraw the figure again. I will do that.
Okay.
But for the draft one, maybe I'm not sure I will able to do that or not.
Focus on writing.
Okay.
Keep scrolling.
Yep. So this one
This one is wrong.
wrong.
Yes. So we will return to it once again. Please scroll further, and then please
Okay.
scroll to the next figure, and then I'll explain why this one. Okay, this one is correct.
Yes. And that one for absorbance.
Yeah. Stop. No. Scroll a little bit down. Stop. Right here. Stop.
Yeah.
So what is x-axis?
The transition energy.
So which? Okay, transition energy. And where are your dots? This purple, yellow, green, blue dots. Are they at big energy or small energy?
This one shows small energy.
Yes, so it's absorption at 0 transition energy, very small transition energy. Very good. Now please slowly scroll up.
Okay.
Now this figure. So tell me, where are the dots here? At small energy or large energy?
Professor, it's wavelength versus absorbance.
Yes. So how wavelength is connected to energy?
Just 1 minute. So in the it's around, we can say that more than 400.
No. Let's make a little interview. But,
Interview.
what is the connection between wavelengths and energy?
It's inversely dependent.
Yeah, correct. Okay, do you hear it?
Yes, yes.
So if the wavelength is small, it means very large energy. So 400 nanometers will be about 3 electron volts.
Okay.
So if you want to show the spectrum and
Mhm.
include low energies, you should expand
Hmm.
your axis to larger value, to like 3 or 5,000 nanometers. Expand it on the right side. And it is what we discussed with Lola maybe 5 minutes ago.
Okay, so I need to read again. Oh God.
Kia, can you stop sharing? I will show something on the screen, and then you will share once again.
Okay.
Okay. So if we are Control C. No, just a second. Yeah. Control C. So if I do GNU plot, GNU bin GNU prog, GNU prog SPE nanometer, right? You are doing this command for the spectrum.
Yes. Yeah.
If you hit tab, there are several additional versions of this command, and there is one, for example, with a range from 300 to, you see, from 150 to 3000. So if you run, now it will give error because there are no data here, but in this version of the script, it,
Professor, could you please allow me to do this one in front of you, because I don't want to do mistake again.
yes. Well, you were planning to disconnect now.
No, I'm not planning to disconnect. I just want to draw in front of you.
Okay. Let me put it into the chat line. Okay. And it just, you can do it manually. It just changes X range for nanometer. So if you plot as function of nanometers, you put U1 versus 3. First column is wavelength, third is absorption spectrum. And for X, which is nanometers in this mode, you put the larger range. Now, please share. I'll stop sharing. Please share your screen.
Yep. Okay. So this one is wrong. So I need to redraw.
You need to go. It's not right now. Your rightmost point is 600, right?
Yep.
And you need to do at least 3000 or even more, which will correspond to a very small energy. And put your dots not on the left, but on the right.
Okay, just 1 minute. Yes. Absorbance. All absorption node. This one. Yes. Okay. Okay. So I need to plot like. Am I doing? Is
Yes.
correct?
Keep doing.
Is it correct or wrong?
You did everything correct. Why are you typing quit?
Okay. DU done. Just After 1 minute. Oh, it's not here. Okay, it's fine. Settings level. Wavelength. Name. Oops, what happened?
Label. I think it is spelling.
LABEL.
But
Nine.
the only command for plotting to save time. The plot command and put your arguments.
Plot. Then this one. Go if this okay. Mm. 2:1. It was 2:2.
One is enough, just for a quick example.
Oh, okay. Just for example.
So right now you are plotting connection between energy and wavelengths, right? On x-axis, you're plotting energy. On y-axis, you plot nanometers, and it is inversely proportional. For the spectrum, can you give me control so that
Yes, just 1 minute. What happened? Control this.
Please allow me to.
Yeah.
Okay. No, I'm only viewing. Please let me type something.
No. Oh, there is another.
Now it is. Now it is. Yes.
Yes, yes. Yeah, you are able to operate that one. Yep, it's working.
So if you really need nanometers for some reason, it should be 1, 3. 1
Oh, yes, yes.
and 3 for spectrum. And of course, like these large numbers are not so informative. So you can set X
Range.
from like 300 nanometers to 3000 nanometers.
Okay.
And then you would put plot on the
Other spectrum.
rightmost point. You would put dot there. So if you see what I'm showing? So
Yes.
you are putting dots on the left.
I need to show in the right side.
Right. Yes.
Right side. I can understand what you want to say. Okay.
Now you can withdraw privileges of typing from me and keep showing your figures.
Oh, what happened? I don't know what happened.
Remove the control from me and just show the figures.
You want to show only this figure? See this figure?
Oh, show me your figures. You were playing. We discussed this. Yeah.
So this one is not correct actually. So I will do that one, and like if I, oh, it's not removing. I need to remove this one. Energy will be this. Sorry, this round one will be there. This one there and there, right, Professor?
Yes, yes. Don't you hear me?
No, now. So I will do that now, and I will show you. I'm not.
Okay.
I'm not leaving. And this figure, just uh, this one for code up. So
Mhm.
this one code up, and this one homo. Sorry, this one homo minus one. This one homo. This one for lumo, and this one for lumo plus one.
Okay.
And here I will
Just
attach later.
keep scrolling. Just quickly scroll
Okay.
until the end.
Yes, the other one for dopped,
Yep.
and this one for undopped.
Mhm.
Finish.
Okay.
Okay.
It's already more than enough for a brief report.
Okay.
And I wonder how you would explain this partial charge densities. It's a lot of work to do it.
Oh, I will, I will
So
explain later.
I think later for your presentation, and if you want to continue the subject, of course, one needs to show molecular dynamics for many steps. But for the brief report due tomorrow night, just I think your figures and their connection are logical, and just start writing. You were right. And maybe do not update the figure, just remove the one with nanometers and just quickly write as much as you can for these figures.
Okay.
Do not forget to put captions for each figure. Captions are always needed.
I will do that, Professor. I just copy and paste. I will do that.
That you were not hearing. You need to be more loud. Okay, so
You are talking about my English professor. Of as yes, okay.
okay, so you're done with your questions?
Yes, and I will stop sharing, but I will do that figure, and later I will share my screen again.
Oh yes, please do.
Okay. Thank you.
There was a quick question from Lola. I think you left raised hand, and then we will talk with Sarah. You're so quick. You're already done with the orbitals.
Yeah, but just for the spin component too, it agrees with the neutral.
And for spin component one, is it different? Yes, but did you do the orbitals look similar?
So I was wondering, how do
Oh, spin component. I know how to do. I know how to do it in the VMD, but I'm a little stupid in this Gaussian. Oi. Know how to convert VASP part charges into how to visualize them in Gauss view for spin polarized case. Then probably keep this ones and start writing, because time is up. But later on we may try to redo the orbitals with VMD. Just show whatever you generate, and because writing is more important than completing thing. And yeah. Do you have VMD on your computer? You hate it? No? That's okay. That's okay. But it's like a free environment. Do whatever you like, but it's recommended. It's like beautiful program that may help you. So you may decide to install it. Okay, Sarah, sorry for delays. Now let's focus on your questions and your project. So, are there any? I don't know if it's heard, but other questions?
I just wanted to show you the molecular dynamic on the BMG.
It's very interesting. And I think Lina will appreciate it because she also did molecular dynamics for horror, and she also studies the adsorption, desorption.
This is my molecular dynamic. Maybe it's new. As you can see, the bottom molecules are kind of going from down to up.
Very interesting, very interesting. So let's change something in the style. I'm completely fine in the way you show it, but there is a way to make it a little more beautiful. Representations. Yeah, CPK, click on the CPK and change it to dynamic bonds. Yes. Bond radius, decrease it. No, smaller. Otherwise, it will be like two thick cylinders. Just make it 0.1. Yeah, 0.1 is okay. Now, maybe increase distance cut off a little. Once again, enough. No, otherwise it will show hydrogen bonds and it will be not as nice. Now create rep. Yeah, now go to drawing method. Do van der Waals, VDW. Yes. Keep going, make it smaller. Okay, yes. And now let's run, and you probably do perspective. Can you please click on the main, yeah, and display orthographic, good. Now let's run molecular dynamics once again and see what is going on. Okay. Okay. So can you please rotate it around Z axis so that yes, from the, yeah, about from no back. Yes, keep this aspect. So also, would you please?
Sorry.
Maybe German will help. Gesundheit. Can you please enhance it so that we focus only on the top part? Maybe. No. Yeah. No. Keep it the orientation as is. Click on the main menu, and select the mouse translate mode. Translate. Go back to the image. Click and move down. Click and click, hold, and move. No, down. Other direction. Yes. Maybe a little bit more down so that we focus on, yes, on enough. Now go back to the main menu. Mouse, rotate mode. Okay, and now maybe orient so that plane will be perpendicular. No, other direction around Z. Yes, stop. Yeah, I think this is a good aspect. So let's, I will ask Lina to just, Lina, would you please help? Just share your ideas, what should we focus at and then I will summarize and we will start. We will try to analyze.
Hello, Sarah. So here, I think you should focus on the hydroxyl groups, OH, and the amino groups, NH3. It was an H3 upstairs. Okay, and then you focus on the hydrogen atoms, how they move from which atom to which. So try to count how the hydrogen atoms around the oxygen and the nitrogen and see what happened.
Okay, yep, yep.
Thank
Sarah,
you.
does it make sense or you want more details?
Oh, can you explain more detail for me? Thank you.
Yes. So I'll probably focus on the board and draw something. Sarah, please stop sharing for a minute, and then you'll share back again. Okay. Up, in. Yeah, they finally returned the setup as it should be. Up, 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 down, down. Okay. Sarah, do you see it? Is it big enough?
Yes.
Okay, so one of the things is to check there is an oxygen on the surface and there is an oxygen on the molecule. So there is a way to track interatomic distance, and one can simultaneously track distance from oxygen on the surface and oxygen from the molecule and see which one is closer. So as we go through the dynamics, it may originally closer to oxygen on surface, and then later it will go here. So this is one effect. And we'll discuss how to track it. If maybe you already know, it's a standard tool in VMD how to measure distances along the trajectory. Now I will focus on this part of the molecule, and I will just erase and redraw. So you have OH, then benzene ring, and then on one side you have carboxylic group. On another side you have amine group. And you have a browsing water somewhere here. Does it look similar to what you have?
Yeah, it seems. Yes.
Okay, so I'm going to tell absolutely the same story as we were discussing with Lina. So by great luck, you both are interested in amino acids, and there are some similarities. So probably you will be reviewers of each other on Friday. So the carboxylic group, carboxylic acids typically have hydrogen here. And then it's called like protonated hydroxyl group. But if one removes hydrogen, it becomes negatively charged, O minus. The amine group, typically it is NH2. But if we put here additional hydrogen, as we have in your model, it is positively charged. And in the initial geometry, there is a dipole going from positive to negative. So it is active. I don't know how to say physically or chemically, but it will bind either, it will affect either connection to this clay or maybe just to a layer of water molecules. So this big dipole means it is unstable and reactive, that something will happen. And one of the chances that we have seen in project by Lina. So the hydrogen, the proton from amine group, or if it is overprotonated, is ammonium, from ammonium group was carboxylic, was transferring to the carboxylic group, and then it was removed hydrogen here, added hydrogen there, and it was a protonation of carboxylic group. Protonation. So I need to inspect your movie more tightly, but you can do it yourself and check whether this proton transfer is happening. So it's a kind of high probability of reaction of this event. Also, since this nitrogen and carbon they're not too far, but they're not super close, there is a chance that this transfer of proton will go in a chain-wise fashion. So there is a like spectator. What? I need to move it a little up. Yeah, there is a spectator. I'm not drawing an animal or smiling face. It's on the oxygen. So there is an spectator water molecule, and it may temporarily absorb this H+, so create H3O+, which is hydronium ion, and then this H+ can chain-wise transfer to carboxylic group. So it's possible chemical scenario. And in some sense, I respect highly force field molecular dynamics, but the DFT that we are doing here has a strength. So it's more, it works better to describe such dynamics where bonds are broken and formed. So it's something complementary to the experience that you do at your main research subject. So what can you do practically? So three things, and nothing is pressurized. You can do nothing or do part of it. It's just suggestions. Sorry, I was typing before I forget the thoughts. So track distances. If we suspect that the distance from nitrogen to hydrogen will be broken, there is a tool in VMD to click to select this nitrogen and hydrogen and show interatomic distance like 1.5 as reaction is going at each time step. And you can select several pairs of atoms and see how their distances are changing along the trajectory. And then you can either watch it in the movie, or you can write them down by pen and paper or in the file and show how the interatomic distances change over time. But it will be a criterion to analyze chemical reaction. So track distance, and I'll show how to do it. It's quite easy and pleasant. So plot snapshots. The movies are really great, and some modern journals allows movie, but standard format of a paper shows only static. So you can show the snapshot before you start reaction, couple of snapshots in the middle of reaction, and then the last snapshot after your reaction is done. Right? And then you can add this as like 4 or 5 snapshots into one figure and put it inside your written report. So snapshots of molecular dynamics. MD snapshots. And 3 characterized product. So take the latest snapshot of the molecular dynamics, extract, like copy, create new directory and copy the cont car of molecular dynamics into postcar in the new directory. And then characterize this last snapshot, the product, the last result of the molecular dynamics for density of states, for orbitals, and see how they are different from what you had before you started the reaction. And then you see how the thermal treatment, how the thermally activated reaction modifies the properties of your system. So based on what we observed together for Luna, there were some objective observation of removal of a dipole, proton transfer, and likely there are some changes in the band gap. So it's quite interesting, and it is valuable scientific information. So, any questions right now?
No, everything is clear. Thank you.
Do you know how to track distance?
Yeah, I guess. I guess I know.
Okay. Can you please maybe share screen and show it?
Yeah.
So that those who are in class will watch it.
Okay. So the first one you wanted to watch is the hydrogen connected to the nitrogen. This one?
Yeah. For example, well, there are 3 hydrogens connected to nitrogen. Let's scroll to the very beginning. Oh,
This is the beginning. This is the 0 frame.
Okay. Well, there could be 2 other hydrogens that do not show connected, but they will be at the bottom. But let's start from this hydrogen to nitrogen and see what happens. Just let's do it as a little example.
Okay.
Yes? If you need to go, yes, please do. You deserve some rest. Okay, so you just clicked on it, yes? And
So
what is the distance? What it is?
it doesn't show it because the background is white, I think. Because of that, it doesn't show. Maybe I should
Yes.
do black.
Yeah, you can do other way. Yeah, I see this distance. Let's click on the colors once again. Colors. So categories. Go over categories. Scroll down. Scroll. Labels. Bonds. Change it from white to black or to like blue. Some cool color.
Right.
Okay, and now it's not the whole story. There is a way to change the font. So close this window. Let's go to check graphics. Click graphics, labels. Select, instead of atoms, select bonds. Select global properties. Global properties, text size, increase it, just pull the bar. There is a little bar that you can, yes, okay, good. And text thickness. Change it like, yeah, change it, maybe even more, make it very, very thick. Okay, and now you can close this window. Maybe change background back to white. Display background white, okay. And play the molecular dynamics once again. So it's it looks like this specific hydrogen is not getting broken. It's just oscillates.
Yeah.
Okay. Yeah, but let's stop at the last step of the trajectory. Just scroll to the end. Now let's rotate it a little. Yes, and you see there is one hydrogen connected to carboxyl group. Can you navigate? So can you show carboxylic group?
The carboxylic group, it should be here, this one.
Yes. You see there is a hydrogen nearby.
This one.
Select this hydrogen and the oxygen it connects to. Yes, and now let's play dynamics once again. So you see this hydrogen was originally belonging to the amine group, right?
Yeah.
And during the reaction, goes. It's still there, still there, and up. Now it jumps to this carboxylic group.
Yes.
So you also observe this chemical reaction of protonation of carboxylic group. So it's quite interesting, right?
Of course.
Okay. So please consider to make the image of the snapshots and explain it. I think it is much appreciated by not only for the class, but generally as a research on clays. Do you have another questions? And everyone is welcome to disconnect or depart. Yep. Do you have, Sarah, do you have more questions?
Oh yeah, I just wanted to show you my figures in the report. Check. This is my first figure for this.
Okay. You're almost done. Okay, keep scrolling. Keep scrolling. Yes, I see.
And then for different up down.
Oh, I wanted to ask you about this. Yes. So keep scrolling and yes, keep scrolling. This is really great.
And as you
So
said,
you did anything I can even imagine. So the singlet is not energetically favorable, right? For n up down 0, it is higher in energy. But if you have doublet, triplet, quadruplet, octuplet, they all are quite favorable. But maybe most energetically favorable are with 1 unpaired and 5 unpaired.
yeah. Yes.
Okay. Yes. Very interesting. Very interesting. Yes. Keep going. Keep going.
And then I have the orbitals plus their.
So let me ask a question. Maybe you already answered it, but for which spin configuration, for which for which amount of unpaired electrons you are plotting orbitals?
I didn't get your question. These are for the HOMO and LUMO, and just for the alpha spin up.
Okay.
For figure 5. And then for this figure, I showed it for the HOMO -1, HOMO and LUMO +1 for the beta spin down.
Good. Do you have more figures?
I don't think so. I have just one table to show the binding energy.
It's really good. Yeah, it's hard for me to demand anything else, but I have a little idea. So would you please scroll to your figure 4? Yes, and point your mouse on n up down equals 0 and energy equals -6. Yes. So this is singlet configuration.
Yes.
And I suspect that your orbitals are computed for this configuration. I don't know, but you should check. But you have computed electronic structure for like 7 other configurations, 1, 2, 3.
Yeah.
If you take other configurations and redo orbitals for them, they will look differently.
Mhm.
If you do, you already showed density of states, but you didn't check orbitals.
Yeah.
So if you try like HOMO-LUMO orbitals, at least for 2 more for n up for the directory where you have n up down 1 and n up down 5, they may look differently, and you can also you probably can extract some valuable scientific conclusions.
Okay, what conclusion?
Yeah, I'll tell you in a minute. And with understanding that there is not much time, maybe you will not be able to complete it for like tomorrow night deadline, but after the revision, you may consider to include it. So let's go up to figure 3. Yes, yes. So your most stable are n up down 1 and n up down 5. So right now I do not have conclusions, but I can approximately tell what they could be. And if Stephen didn't expired his energy and patience, I will ask you to stay with us for a few minutes more and help to talk to Sarah. So Sarah, will you please stop sharing, and Stephen and myself will draw something on the blackboard. No, maybe on the other one. Okay. Oh, this blue is good. So Sarah does have iron, Fe, just draw it in the center. And it is coordinated to 6 oxygens. Just sketch, do not do 3-dimensional. Okay, so by now it's clear, right? Now, how many d orbitals are typically available? Is the question clear? I know that Stephen and Boston know the answer, but Sarah, please answer. What is the number of d orbitals, if you remember?
No, unfortunately, I don't remember.
Okay. Yeah, let's do this little educational thing. How for given principal quantum numbers, how many s orbitals are available?
You mean for the
S orbitals. How many?
1?
Okay. How many p orbitals?
Or 3?
Okay. How many d orbitals?
I am waiting for you.
Huh?
I am waiting for you.
So between s and p, the difference is 2. From 1 to 3, the difference is 2, increment by 2. So guess how many d orbitals?
5?
Yes. So if the iron is isolated, if it is just iron in vacuum, then it will be 1, 2, 3, 4, 5 d orbitals. But if there are oxygens nearby this iron, then these orbitals change their energies. And now Stephen should teach us how they are changing due to presence of this oxygen ions. Just please erase and update this figure. Okay. So total number of orbitals is 5. and they split, 2 goes up, 2 goes down. Sarah, does it make sense?
Yes.
Okay. This is energy. And typically, these iron orbitals, they are between valence band, between HOMO of the clay of the rest of the ions. It's better called valence band field, and between the conduction band unoccupied. And when you change, and suppose we have it a certain number of electrons. So by changing, suppose we have like 3 electrons, but I can be wrong on this for this compound. So if we have totally 3 electrons on these d orbitals, 2 paired, 1 unpaired, what would be total number of n up down? Bad example. Let me do it this way. Okay. Yes. So if you have total 5 electrons on d orbitals, 4 are paired, like 2 up, 2 down, plus 1 unpaired, plus 1 up.
Okay.
What will be the value of n up down?
1.
Yes, correct. So 1 unpaired electron. And if we set up n up down, n up down equals 5. How should we ask Stephen to rearrange electrons on these orbitals? He should erase all of them and then put 1 up electron on each of the d orbitals, right?
Yeah.
And then the band gap for alpha electrons will be much smaller.
Mm-hmm.
So even if we keep the same charge, but we vary the spin polarization, there will be drastically different band gap and drastically different color. And from the color of your clay, we can say what was the band gap and what was the spin polarization. So it's one thing. Another thing, the larger n up down, the stronger are magnetic properties. So if it is like n up down equals 5, it means it is strongly magnetic material, and one can pull this clay with a little magnet. If it is 0 or 1, it will be less magnetic.
Yeah.
So again, there is, yeah, thank you, Stephen. I think we are done with this little illustration. You want to add something?
This would be like almost a better state material.
Yes. Yes. Yep. So based on the experimental observation, what is the color and what is the magnetism of this clay, we can reconstruct back if the hypothesis that n up down 5 was more energetically favorable. And it is, I understand it very much that probably there is no time to do this additional calculations and figures, but just wanted to give you heads up how you can plan to expand it if time allows, or what to write in conclusions, like the future steps in this research are this and that. Make sense?
Okay. Yeah.
Okay.
Thank you. Thank you so
Any do you have any thank you, Stephen.
Representation question DP, but
Good. Yes. And feel free to send me emails anytime. I'll maybe not answering immediately, but I will look. I read emails until like 1 a.m. and start reading them 6 a.m. Okay. So Sarah, any like questions or suggestions?
No, I'm good. Thank you.
But I was not intending to make your mood worse and load more tasks. It's just showing horizons, what can be added and how to interpret your data.
Yeah, thank you so much. I really appreciate it.
My pleasure, my pleasure. So I believe Boston has more questions to me, so I'm going to talk to him. But
Professor.
yeah, will you, Sarah, okay, do you have any questions, or you plan to have
Yes.
more questions? Yes.
Yeah, I have. I raised my hand and you didn't see this one.
You want to show something?
Yes, yep.
Is it Boston? Oh, oh, okay.
Just 1 minute. So, Professor, first I was trying to plot CODOP, DOP, and UNDOP together, but they showed that they are not able to open one file. So, what I did, I make another directory and copy all spectrum file there from there, and then I plot this figure. So here I have one question that for the UNDOP, there are several spectrum there, W005, 10, 15, 20. So um, I here I plot for each spectrum using UNDOP, but CODOP and the DOP with phosphorus and fluorine, and that one is fixed. So which figure should I choose, like for the undocked one?
I understand the question. I do have an answer. It just takes me a few seconds or a few minutes to convert thoughts into words. Sorry.
No, no, no.
So we have a procedure of converting discrete orbitals into continuous density of states.
Yes.
And in this transition of in the equation for density of states, we do have one orbital gives one delta function or one profile, one Gaussian function. We do have a width of this Gaussian function as a parameter. And this 0, 0, 5, 0, 1, those are replicas of the density of the spectra, same for spectra, computed based on the same list of discrete transitions, but with different width parameter.
Yeah.
So if we are interested in absorption at very low energies, then it is safer to use larger width parameter. If you use it too small, then it can drop too rapidly. So basically, you should you have a freedom as an author to select the width. Ideally, if the time and resources will be unlimited, it's better to use this. It's more correct and healthier to use the same width parameter for all 4 figures.
Okay.
But, right now, since the final results are different by several orders of magnitude, even if you use slightly different values of this width parameter for different lines, your main conclusions will be not changed.
Okay.
So I would use 0.01 or 0.005. But
yeah, so 0.005, it's this one, the dollar sign for the undocked.
so it
And
drops further. Then
yeah,
use the next one with a little bigger.
yeah, that one.
Yes.
Yeah. Okay.
Okay. Then you understand everything
And
yourself.
Professor, oh my God, oh, it's difficult to speak. So Professor, I showed you the all figures. So these are really enough for the class project.
Yes, yes. Do not worry. It's just start writing. It's
Yeah, I already start introduction part. Then
same. I was. Don't forget the captions.
I will not. Obviously. Okay, thank you. And Professor, another thing that I already submit the new new job for the heat analysis, and it will be finished uh, within 22 hours.
Okay, so it may be not sufficient to be for the draft of the first draft of the report, but it's definitely will be sufficient to include into final draft and
Yes,
presentations.
yeah, I'm thinking about that. So for the final, okay, I already sent you email, so I don't want to repeat the question. I already sent you email. Is
Okay,
it?
yeah, I think you are in a very good standing. Just keep going in writing, and I look forward to read your work.
Yeah. Okay. Sure. Thank you.
Any other questions?
No question.
Okay, then I will speak to Boston, and it may take, I don't know, about
Professor, it will be better if you just give me the little bit explanation of one figure like this one,
please share.
like this charge density. Okay, let me show you the large figure. Suppose this one.
Okay.
Any of this.
Yes.
This one Lumo.
Yes. Hypothetically, of course, we cannot do everything in at once in one work, but hypothetically, you can imagine that we remove in your model you have 6 oligomers, right?
Yes, yes.
They're stacked from bottom to the top. One can imagine a calculation where you remove 5 and keep only 1 oligomer.
Okay.
Right?
Hmm.
And can you scroll through your figures? I maybe select another one which will look a little easier to describe. Okay, yeah, this one is better to describe. Okay. So suppose you remove first, second, then keep the third, and then remove 4, 5, and 6. So you keep, right?
Sorry, I don't understand what you say. That remove this one, this one, this one, and this. You're talking about this one.
Keep look at the left panel and
This.
look at the maximum. So we will keep only the oligomers that gives this maximum.
Yes, this means maximum value.
This strength, only this oligomer.
Mm-hmm.
Now, the lowest orbital, frontier orbitals, either HOMO and LUMO, will follow the pattern, the space distribution of particle in the box, which means there will be 0 probability at edges and maximum probability at center. So if you look on the lower panel, panel C, it shows the envelope function for particle in the box. It is a maximum in the center and minimum on the edges.
Yes. Yep.
So it shows like frontier orbital, like ground state for particle in the box. And it is not a continuous line, but set of peaks because probability density is localized only on atoms, not in the space between them. Okay. Now, so it is an explanation of the panel C. It's a pattern for the particle in the box. Now let's look back on the panel A.
Yeah, this.
Since there are 6 oligomers, there are peaks of different height to each of the oligomer. There is a little peak for first oligomer. If you go between z-axis between 0 and 2. Yeah. So this peak is quite not intense. Then there is a next peak near 4 angstrom. It is quite high. And there is a third peak near 8 angstrom. 8 go up. Yeah.
This one.
Which is very high. So it means the third oligomer is mostly populated. The electron is on the, or hole is on the third oligomer. But since pi orbitals of different oligomers overlap, since we stack these oligomers close to each other, there is a chance of electron or hole hopping, jumping between different strands. Therefore, orbitals, there is a hybridization of orbitals between different oligomers. And this effect of hybridization of orbitals between different oligomers is one of the strongest part of your model and of your work. So it is exact realistic situations that happens in practical conjugated polymer materials. And it is a aspect that typical calculations with Gaussian that most of people are doing are not available. So you can explain realistic mechanism of charge behavior in the bulk conjugated, in the compressed matrix of conjugated polymers. So this pi hybridization between different oligomers is quite important characteristic of your model. And by exploring different variations of your model, like injected, doped, and different orbitals, you can say more about conductivity. So by analyzing these orbitals, one can explain elementary mechanisms of the conductivity. Is it enough?
Yeah, thank you so much. Thank you so much, Professor. And Professor, if I have any question, I will send you email because I'm just started writing, and most of the, I'm thinking about the introduction part. I will be finished within few hours.
Huh?
So if I have any question, obviously I will have. Then I will send you email. Is it okay?
Okay. Yeah. Very good.
Okay. Okay. Thank you.
Thank you.
Professor, maybe I can leave now.
Yes. 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 Feel free to disconnect.
Okay, bye. And Professor, one thing, what happened, Sarah?
Oh,
I'm here
yeah.
to say goodbye and have a good night.
it's a cute part of our class. The best student.
Yes, yes.
Okay, have a good night. Thank
Yeah,
you.
good night.
Bye.
Bye bye.
Good night. Good night,
Good night.
Professor.
Boston, I will quickly answer a cell phone and we'll be with you. Hello? Да, спасибо. У меня еще один остался, но я сейчас с ним быстренько разделаюсь. И к 9 точно уже убегу. Ладно, хорошо. Ну все, целую. Давай, пока. The question was, are there really students who sit 50 minutes after hours?
So I've got these pictures here.
Yeah, especially anion. It's what.
Yep.
And cation. Yes.
Yep.
It's really great. I already see. You don't need to explain.
Okay, I was just gonna say, if I'm not mistaken, I remember for like singlet, doublets, triplets, those kinds of things, you have to have both alpha and beta ones, and I forget how to make those ones. I keep looking back onto the labs to see and try and find it, and I'm only finding ones that we've done it on Gaussian. It's probably hidden somewhere in there, but I just can't find it. Also, this is my spectrum too.
Yeah, spectrum is great.
Okay. I did make these pictures as well with
as we discussed with this updated code. Good.
But like I said, I wasn't sure if that's how they're supposed to be done since.
No, just looking on the pictures, it looks very adequate. So for, do you remember from homeworks the triplet density of states? If you don't, it's fine. Just
I don't exactly off the top of my head, but this is what I have for like the triplets.
No.
Yeah, I didn't think it was right either.
Yeah. So let's quickly bring me to this directory, and I don't care which. well, I care either photon or CCast. Oh, either photon or NERSC, not CCast.
Yeah. So here,
Okay.
this is in photon. So
Okay, so T minus N, let's say. So many. No, okay. Phew. Okay, let's just look over the whole thing.
I can open it up in a notepad too. That might be
No,
easier.
no. Almost there. Yes. So spin component 1.
Okay.
And if you look for all K point, everything
Mhm.
from here until we see the keyword spin component 2.
Yep.
We just take it and copy into a separate file.
Mhm.
Just imagine it.
Mhm.
Now grab say just 50 spin space two. And then, so there are so many K points for spin component 1.
Mhm.
And then after spin component 2, there is the same amount like repetition. So now let's look for everything after spin component 2. And you see there are like 39 is occupied, 40 is unoccupied. If I do after spin component 1, what was the occupied and
I think it
unoccupied?
was 39.
See, it is drastically different. And therefore, if we take everything with spin component 1 and collect it into states as you did before, but we call it states up.
States up. Okay.
And then we take everything after spin component 2 and place it into states down.
It says states underscore down and states underscore up.
Without underscore, just states uppercase, states lowercase down.
Okay.
And then after you're done with the scripts, there are, after you prepare these files, there are scripts that basically convert states up and states down into DOS up and DOS down. And then there is a gnuplot script that combines them into images that look like just let me show that you know what to expect.
I think I remember. They kind of look like they're sort of mirrored.
So it will be red color here and blue color there, and the homo and luma will be different for these components. And we may need to recompile the scripts because I never addressed DOS. Yeah, thank you. Just let's look what is available. Dress DOS up and dress DOS down.
Okay.
Okay, and there are .f, which you can try it yourself or you can delegate it to me. to
I was
rename it
just-
as dress those up huge and change the size of the array and recompile.
Is there dress dots up huge or just?
No, no, no. I designed this huge based on your request. I never, for last 12 years, I never thought it could be
Did I
ever
do too
needed.
many K points in my thing?
Yes, yes.
Because that's how many K points were in the original file
Mhm,
that you had sent me.
mhm,
So I was just like, oh, that's what I should use.
But now you see why postdoc declined to do it.
Yeah. Alrighty. So I'll go and I'll try making those, and then I was going to then ask, or yeah, I think I figured that out now.
Mhm.
Next thing I was going to ask about was I ran my
Mhm. MD.
yeah, MD, but I just found out it gave me something that doesn't make any sense at all.
Please show, please show.
So if I go back to the beginning and I run it, so it's running right now.
It looks like you didn't heat it up.
Um,
What was the temperature?
I can show you my in-car.
And can I do something?
Yeah, things like bounce around, but
Yeah, probably you shouldn't show it to anyone. Oh no, maybe you should. Display orthographic presentations. Create rep. Or dynamic bonds. Okay, yeah, it makes sense. Now periodic plus minus VDV plus minus minus. Okay. No, it's perfect molecular dynamics. Do not.
oh, it is.
Yes. It's really interesting, and you already put foot in the door for like 2 years of at least 2 years of research ahead
Okay.
without any problems. Just so. Speed is already maximal.
Yeah, I did 2,000 steps.
That's good. That's good.
I didn't like. It didn't make sense to me that they jump around so much. Like,
Well, if you look on the central portion, and if you do not consider these bonds, which it doesn't draw bonds across periodic boundary conditions, then it's just oscillations, right? And since both bismuth and telluride are quite heavy, they're like 150.
yeah, and I only did this at 300 Kelvin, so.
So it's just inertial motion, and it makes just few oscillations during this period. So there are no drastic change of structure. And the visual appearance of this style. And once. If you put them large enough or small enough, the bonds will stay the same for forever. So it just draws line when they overcome some threshold.
Okay.
So it's on one hand it is boring. It's not as chemical reactions for these two varieties,
Yeah.
but in the like if one considers it as a just trampoline for a bigger project. This boring molecular dynamics near equilibrium allows to screen several points of phase space and allows to compute the non-adiabatic couplings that will bring considerations beyond Born-Oppenheimer that would allow dissipation of electronic excitations into lattice dynamics. So just prepare a movie, including to report and for in presentation, and in report you can just either show couples of snapshot or just type that I did run dynamics. It looks boring. It's just oscillation of Telluride to Telluride and lead to Telluride bonds. Let me temporarily stop it and do the things that Sarah taught us. Mouse, label, mouse, bonds. Strings. Mouse, label, bonds. Well, we will not fix it now. Oh, it's toggle top active drone fixed. Forward save coordinates. Double click. It's a little.
I can.
Yeah,
At
yeah.
home too.
But you can select a bond
Mhm.
to track it, and then you can do. I don't know if you are doing it, but the movies. Were you practicing it? Not yet. Please select directory where you save your data for this model. Okay. Now, slower movie is good for here. So movie settings, one with trajectory, MD 300K format. Oh, you did set video map. Excellent. No, it's quite quick. And then after it is done, you can you have some Google account, right?
Yeah.
And then you open YouTube and upload and share a link with me, and then play it during the presentation.
Okay.
Again, it's quite boring for the system, but it is like step forward. You can puzzle others like what these little jumps are, but it is nothing but if system moves slightly across the periodic boundary, it recounts as it like different pair of atoms come
Okay.
inside the box, like two atoms, they are connected, and or maybe three atoms, two connected, two are disconnected. Now they come this way, nothing is connected. It comes this way. Now this one will be connected to this one through here.
Okay, that makes sense. I was wondering why like they pop in and out, but yeah.
And see, as we speak, it's almost done. It after it goes over all what it does, it creates 2,000 files of images, and it shows stage 2 of 8, and then it uses this video Mac, and it glues together images into one MPG or MP4 file, and but it will, like, this is the longest part. It will be done very soon. Don't worry about it.
Then I had another question about, I was going to ask too, did you ever get a chance to look and see if you could get that spectrum command to work with my energy states?
Yes and no. Something is wrong with video Mac.
Yes.
And then you just do start, right? It's quicker than analogous program on the Mac. 31 megs is okay. And now check if this file is available. If there are big, yeah, MD.
I miss it.
MD.
Oh, there it is. Yeah.
And what's the size?
It is
Okay.
about 31. Yeah.
Now let's go to like YouTube on Google.
Uh-oh.
Yeah, it's good, but let's go to upload it right away. It's much after you upload it to YouTube, you can delete it here if amount of hard drive is limited. Plus upload video. Up, yeah, select files. It's the same. And it will ask some silly questions like, is it for kids? Just scroll a little to the left. Yeah. Scroll to the, yeah. Keep scrolling. Yeah, no, it's not made for kids. Otherwise, it will, yeah. Next. Next. Yeah, all of this. Next. Public is fine. Yeah. And then after it is done, you can send this link to me, or and you can watch yourself. It's more. I don't know about resource of your computer. If I do many processes on a laptop, it gets a little tired, and it's working with fans like crazy. But if it just plays something on YouTube, it doesn't take resources. And there is objective explanation. It is going slow because it's like high inertia.
Alrighty, sounds good. I'll get that worked up. And then,
So for Spectre,
oh yeah,
is it okay, or maybe go into
I think
different
this is
direction?
Nurse must have kicked me out.
Yeah, Nurse is better. So
I
is it okay if I go away from this directory?
Yep.
CD. So I have a collaborator who debugs programs after me. I write first draft and he debugs errors, and he recommends to use this version of the code that you read the file with key points. And if there will be errors, one may change again the numbers at the beginning of the file and compile with special keys to enable compiling fortune. So maybe there will be no time to finish it before the due date for the report, but it's some toy.
Okay.
Like kids play toys by breaking on apart. So please do.
So this is what I would run in the energy state and
Right.
or energy pop input overlap thing and wave car.
Mhm.
And then
And this would naturally screen over all key points.
okay. And then
I do not promise that it will work right away from the first attempt, but it is designed to screen over all key points and look for direct transitions with spin, not spin, momentum conservation.
okay. All right, I'll try that one then.
Okay.
And then I think I have
And-
a last question.
Yes, please. Orbitals.
Yes.
Okay,
So it might end up being a couple questions because
that's okay.
so this is on CCAST. This is where I ran at least one of my par charges for my anion.
What was iSpin?
This was my in car.
Yes. So what is iSpin?
I didn't set it.
So iSpin 1 with 2 electrons per orbital. Okay.
But it didn't write any of the par charges when I ran it. So that's what I'm asking about. I don't know why that didn't do that.
What? Okay. So number of bands and number of electrons match. What do you have?
Yeah, so when I ran just the regular one without trying to do par charges, this was the output.
What is the size of the wave car?
The wave car, it is 107.
Okay.
megahertz.
Yeah, it's healthy.
And this was my in car just for the regular run. And it's pretty simple, I think.
Yeah. Number of electron 86 and number of bands. Oh, did you check number of bands?
Yep, the number of bands that would be in eigenval would be 55.
Send me the link.
And I checked. The only one it actually worked for was the neutral one. All the other ones, my anion, my cation, my singlet, doublet, triplet, none of those other ones worked. And if I can figure out what the issue is, I can run them again because they only take about half hour each. They run like 2 or 3 at a time. So, but that's what I did get the charge car, and I was plotting up the charge cars. For the numbers and things, so-
That's good. That's good. I don't understand why the code is not working, but I understand why it could be physically strange. It is the issue that we discussed yesterday or 2 days ago. The same orbital can be occupied or unoccupied depending on value of k. Also, unless there is really need, it's better to use low precision to do things quicker. There should be the keyword that tells to integrate over all k points in one orbital. Separate band, every band separately. Let's read. Of course, maybe it's not possible until the first draft of the report due, but let's read VASP manual and look for like this LSEP-B, and it will give what is connected to LSEP-K. Yes.
Oh, L sub K is what I need.
Yes.
Let me go back.
Yep. Specifies where the charge density of every key point, right? Or whether if the merged file is written on the weight of each key point. So just try to redo it with LSEP-K equals true.
Okay, should I keep L sub ban
Yes.
true as well?
Yes. So, and then just be ready that it will create as many replicas of each band as many k points you have. So it will be like large number of files.
That's fine.
But it will be quite interesting.
I've been getting pretty good about writing Python code to handle all that. So, and then the only other last question I have, I think,
Good.
is you sent me this email not too long ago where it showed that I never figured out how to create that. So I can make this. It's just how do I create that band?
So I believe I don't remember how, but I believe I was able to plot orbitals without any tricks.
Okay. And is this just like?
But it is no anion cation. It is neutral.
Okay.
And then the orbitals, the blue and red, are HOMO and LUMO. Then for this small model, it is okay. But if you would have some like 1,000 more atoms, three-dimensional are not quite comfortable. And also one may need to analyze charge transfer feature. So if this is Z, this is X, and this is Y, we can integrate, like slice with same Z but different X and Y and put it as one point. And you see this red things give this solid, and blue blobs give this dashed. So it shows where is HOMO, where is LUMO, and it shows that the HOMO is on Telluride and LUMO is on bismuth. So it's like redox bond formation. Make sense?
Yeah. So just use this.
Yeah.
Okay. Sounds good. Because I was gonna try and create them for anion.
No. It's already enough material, and I think it is a big challenge to glue all parts together.
All right. So.
Was the last question you have some?
I think that was it. I was just trying to think of anything that I had.
Okay.
Else,
but send me an email. I'm curious and will answer. Just will try to go home and convince that there are students who are ready to stay 1 hour and 15 minutes after the class. No. I'm happy. I'm happy. It's much better compared to if it would otherwise.
I'll be honest. I've been getting